Oh, your name is Ada, not Sue. I'll try to remember that in future. Okay, I'm going to click go live. So we are live on YouTube. Good morning. Lots of you here now. Okay, we are live, which means I can close this tab. Oh, that's taking a little bit longer than usual. Okay, and then click present and resume sharing, and we should be exactly where we need to be. Now, this is very interesting. We've had about a minute and a half on the poll. I'm going to leave it up for a little bit longer. Let me know, can you see each other's comments in the Q&A right now? Can you see each other's comments in the Q&A right now? No, 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 no. Great. That is exactly what I was hoping. For any of you that were here for Jono's Up and Atom lesson, you may have noticed that there were quite a few comments that lots of you could see, and I've had a look into it, and we think we've worked out why it was happening and how we're going to make sure that it doesn't happen in future. But I'm glad to see that. Okay, we've had 2 minutes for the poll, so I'm going to end that one because we do have a second warm-up question. Loneliest, as lots of you have selected, well done to 22 of you that selected option D. Loneliest is a superlative adjective. Now, if you don't know what any of these words mean, don't worry, I'm going to go through them now. So an abstract noun we know is a noun, and a noun is a thing, or person, place, or thing. An abstract noun is a person, place, or thing that doesn't have a kind of physical representation. So something like a pen is a kind of a common noun, and you can hold a pen, you can feel a pen. But abstract nouns are things that you couldn't hold, you couldn't feel, such as freedom or justice. Lots of emotions are abstract nouns: happiness, sadness, love. War is an abstract noun, because even though certain parts of it do physically happen, the overall concept of war is not something that you could put in a box, for example. So an abstract noun is a noun that doesn't have a physical representation. A comparative adverb. We know an adverb is a word that describes an action, like quickly, slowly, happily. A comparative adverb is one of those words that compares it to something else. So it could be, I ran quicklier than Jono. I don't know if that's true. He looks like he's quite a fit person. He probably can run faster than me. But quicklier is the adverb that compares the ways we ran. Conjunctions are words which link two clauses together. So I'm going to have Marmite on toast for breakfast because I love Marmite. Two separate clauses that make sense on their own, joined by the conjunction because. The superlative adjective, which is the correct answer here, is an adjective, which you know is a word which describes a noun. But superlative is a word which describes it being as the most of something. So we could say that Fran is the tallest girl in her class. Tallest is the superlative adjective that describes she is the most tall. And finally, an indefinite article. An article is a word like a, an, the, those. And indefinite means it's unclear how many, or it's unclear which one it is being referred to. So if you said, can you pass me that book? That's a definite article because you're saying very specifically, that is the book that I want. If you said, can you pass me a book? Well, it could be any book. Who knows? You could go to a whole shelf of books and just choose one at random because they haven't specified, they haven't been definite in what they want. So an indefinite article can be a word like a, or an, or any. So a little bit of a grammar lesson there. We're going to have a look at our second warm-up question. We're going to have much less time for this one as we're already at 11 o'clock. Let's get the poll going. I'm going to give you just 30 seconds for this one. This is a slightly more interesting question. In fact, while you're answering this, the reason why in that previous question, let's see if I can get us back to that previous question. I cannot. The reason why a picture of the solar system appeared in the top right is an interesting fact, is that there is a star known as Fomalhaut that is often referred to by astronomers as the loneliest star in the sky. Because if you get a telescope and look in a particular part of the sky, it's the only star that's there. In most other places, there are lots of stars that can be seen, whereas in that particular area, there's just the one called Fomalhaut. Okay, we're going to end the poll there. Lots of you very confident with your collective nouns. Collective nouns is the word for a group of something. And we know that a group of flamingos is known as a flamboyance of flamingos. What an interesting word, probably due to the fact that they have a very flamboyant color to them, which is apparently as a result of all of the krill that they eat, that they filter feed. Okay, we're at 11:02 now, starting slightly later than usual, but that's not the end of the world because we've got what I think is going to be quite a simple, speedy lesson today. Before we get started, we can see that we're going to be looking at nets and cubes. If you were here for yesterday's 3D shapes lesson, you've already learnt about this a little bit, so you're going to be able to put your learning into action. We're here for Lunchtime Logic. My name is James, and here in the Q&A, we have got Natalie here to help you with any questions that you may need support with. Now, in today's earlier up and atom lesson, it became clear that our Q&A was not working in exactly the way that we wanted it to, and was becoming a bit of a distraction to some of you. So we've had a look into this, we've worked out why it was happening, and I've just put together a slide here to make it really clear what we're going to be doing going forward. So we want everyone to be able to use the Q&A when taking part in the live lessons, because we find it helps to keep learning fun and interactive. We found that the Q&A is not performing how we would like it to, and it's becoming distracting. We found the reason for this is that when a question gets answered, it becomes public. So I can see that there are lots of comments from lots of people here. Currently, we've got 141 comments. I can see all of them. Natalie can see all of them, but nobody else can other than their own comments. And that's exactly what we want it to be. However, as soon as I type an answer, and we can see this here, I can type an answer to Haley's question, Natalie, and then I can click send privately, and that will probably now pop up so that all of you can see that question. And the reason why that became so distracting earlier is because when I was running the Q&A in Up and Atom, I was really excited. I wanted to say hello to everybody. I wanted to answer everyone's comments, but it then meant that everybody was starting to see them. So from now on, the co-trainer, which now is Natalie, is only going to answer questions if it is absolutely necessary. So if you've got something that's a really important question, or Natalie thinks it's a really good question which helps to build upon learning that everyone should see, then she'll answer that question and it might pop up and you might be able to see it. But we're going to really try and minimize how often we are answering those questions so that it isn't too much of a distraction. But hopefully that is going to be better. Okay, we're looking at nets and cubes. We're going to think about nets from 3D shapes, and we're going to think about rotating 3D shapes as well. If you already feel confident about this, then that's fantastic. Someone's asked a question here, how is quicklier a word? It might be better to say more quickly rather than quicklier and quickliest, but it is technically a word. Pratham has asked, what is Marmite? That's a very good question. It's a kind of a British staple, something you can spread on toast. But if you haven't tried it before, definitely worth giving it a go, as it's quite a polarizing thing. Okay, let's have a think about nets and cubes. So we already discussed this yesterday. A net is the 2D shape. And when we say 2D, we mean two-dimensional. And what that means is it is a flat shape. Anything that is 2D only covers a plane, a flat surface. So a square, a rectangle, a triangle, a hexagon, a pentagon, all of those are two-dimensional shapes. And a net is the two-dimensional shape that is an unfolded version of a three-dimensional shape. Three-dimensional being shapes that take up real space, they take up volume rather than just the space on a flat surface. So we can see here we've got this net, which is a kind of T on its side. And if you were to imagine that on each of the lines, there is a hinge where it can fold, this shape eventually folds up so that it's kind of like a box. And then that last right-hand side is almost like the lid that goes onto the top. And this forms a cube, which we can see on the right-hand side. When we're thinking about 3D shapes, there are three different characteristics or elements that we need to think about. We need to think about faces, which are the flat surfaces of a three-dimensional shape. We need to think about edges, which are the lines around the edge of each face. And we need to think about vertices, which are the corners where the edges meet. Those are the pointy bits. When we're thinking about nets, we need to determine whether or not a net is viable. And viable means possible, whether it can happen. And so all of these nets that we can see are viable nets. What that means is you can fold them up and they will become a cube. But you could also arrange 6 squares into other orientations where it wouldn't be a viable net. What that means is it couldn't fold up to be a cube. If you had 6 faces all in one line and folded them all together so that they met, what you'd have is a kind of hexagonal prism, but no faces on the top and bottom. It would basically be like a hexagonal tube. So when we're rearranging, when we're arranging these 6 squares to form a net, we need to make sure it is viable. And the reason why these nets have been colored blue, yellow, and orange is to give you an indication of where the opposing faces are. Opposing meaning opposite. So we can see that in all of these pictures, the orange faces will end up being at either end of the cube. The yellow faces will end up being either end. The blue faces will end up being either end. And this is an important characteristic to be mindful of, because this will help you in determining whether or not a net can make the cube that you're asked to make. So look out for viable nets. There are 3 rules that we can consider when we're trying to work out if something is viable or not. The first rule is the Dud Rule. And this is your easiest rule. It's just simply look at the pictures on the faces of the net, and then look at the pictures on the faces of the cubes that are the options you have. And if you can see any pictures that don't match, it's a dud. And we can see this, look. We can see that on the right-hand side, we've got, in fact, let's annotate this, shall we? On the right-hand side, we've got a dark blue rectangle here. Well, there aren't any dark blue rectangles on the net, so that couldn't possibly be one of the answers. Similarly here, we have got a light blue triangle. Did I say rectangle previously? I meant triangle, if I did say rectangle. We've got a light blue triangle, which is great, but these 2 faces are not on the net. We can see that we have got faces that is solid blue with a white cross and solid white with a blue cross, but those are diagonal crosses on the cube, whereas we can see that these are kind of straight crosses on the net. And so once again, that could not be made from this net. So the Dud Rule helps us to identify when, simply put, the pictures don't match up. The next rule we can consider is the opposite rule, and you would have seen this yesterday if you were in the 3D shapes lesson. We're thinking about those opposite sides, and this is why we cast our mind back to that previous picture with the nets that had orange, yellow, and blue faces. We need to consider whether or not things could be opposite to each other. If on a net, 2 pictures are side by side, that means that they're going to be adjacent on the cube as well. If they're not side by side, if they are a certain distance apart, which we'll come on to, they would need to be opposite each other. And when we look at a picture of a cube, we will only ever see 3 faces. We won't see opposite faces. So if we're seeing opposite faces on a cube, or if we're seeing opposite faces on a net that appear adjacent on a cube, that cannot be correct either. So here we can see that the rule for opposite sides is that they will either need to be 1 column apart with a gap, 1 row apart with a gap, Or it could be, as is the case with this right-hand picture, both. But they could never share a side. Those would not be opposite on a cube. And they can never share a corner because those will also not be opposite on a cube. It might be slightly trickier to work that out with the top right net. But if you imagine how we could fold this up, we can imagine that this lower right-hand face can be my hand here. Imagine that there's a circle here. We've then got the white face that was going to fold in. And then above that, we've got the circle, which is going to fold on top, which would then mean that there's a circle on top face and the circle on the right face, which are adjacent. Adjacent meaning side by side. So if we're looking for opposites, watch out for where they could be spaced on the net. Oh, let's turn off annotations. The final rule is the orientation rule. And this is the one that's really going to challenge you to visualize how things can be made and what they will look like. And this is because you are going to have to construct this net in your mind. This is a really impressive skill to have and makes a really big difference with spatial reasoning, being able to work out how things fit together. So what you would need to do is actually imagine, just like I did with my hands in that previous picture, how the different elements can fold together and what the shape will create. So we can see that if we just imagine the three faces on this side, because that's what the cubes are representing, we can imagine how they would fold together. So we've got the triangle face, the diagonal line face, and the circle face. And we can see someone saying that the sound is quite quiet. Let me interrupt myself for one moment and see if I can change to a different microphone. Give me one moment. Let's see. Okay, I've switched to my computer microphone, so I can get rid of my headset. Is that any better? Say into the Q&A, and then Natalie can pop me a message just to see if it's better. Perfect, that's great. We'll stick with my built-in microphone from now on. Okay, so we're just thinking about the three faces that I've drawn the arrows to: triangle, diagonal line, circle. We can now imagine where these faces are. So we've got triangle, we've got diagonal line, we've got circle. And we know that the triangle and diagonal line are going to fold in to each other. And then the circle is going to fold up like this. So we're going to have triangle pointing down to circle on this side and the diagonal line pointing to that central point. And we can see in these two cubes, the diagonal line is pointing to the very center where all three of those meet in both. So that is correct. The circle, because of the nature of how a circle has rotational symmetry, is always going to be in the right direction as well. So we can see that the top face is in the right orientation. But we know that the tip of the triangle would be pointing towards the circle, as that's where these two faces would meet. And this means that this second cube cannot be correct because the point of the triangle is not pointing towards the circle. So the orientation rule is very important to look out for as well. Let's give this a go then. Let's get that poll going. Here we go. Which cube can be made from this net? You may also see questions that say which cube cannot be made from this net. I find those a little bit trickier. So think about your three rules. Are there any where you can just say, well, that shape doesn't appear on any of those faces, so it can't be the option? The Dud rule. Think about the orientation rule and the opposite rule. If you can see on the net that there are two shapes spaced one lane or one row or column apart, but they're appearing adjacent on one of the cubes, that can't be possible. Gonna have 10 more seconds for this. Okay, we're going to stop there and let's share those results. Okay, so we can see that lots of you have opted for E, but a fair few have gone for A and C as well. So let's use the process of elimination to go through this. I'm going to annotate, and I can see someone has asked for purple. So let's give purple a go. I do agree with you, Leon. Good comment. Quicklier does sound wrong. I think it is technically a word, but it doesn't sound right. I would often use more quickly if I was speaking to someone. Okay, so let's have a look through. Let's think about the Dud rule. So I can see that on this net, we've got black circle, green triangle, blank face, horizontal black line, green face. So have a look and see if any of these have any pictures which don't appear on the cube. No. So there's nothing I can immediately rule out with the Dud rule. All of the options A, B, C, D, and E do have faces which appear on the net. So next, I'm going to think about the opposite rule. And so this is where I think about the lanes, whether that's rows or columns, and think, are there any faces here that are opposite because of the net that appear adjacent in the cubes? And I can see here that we've got this green triangle, and then over here, we've got this black line. And these appear with one lane in the middle, which means they will be opposite when the cube is constructed. But I can see with option D, the green triangle and the black line are adjacent on these two faces. And so I know that that cannot be a reconstruction of the net because those faces are not opposite. So using the opposite rule, I can rule that one out. Are there any others that I can do that with? Having a look, there are no others I can do that with straight away. And one of the reasons is because there are those two blank faces. It could be that one is there and the other is not. So next, I'm going to think about the orientation rule. And this is where you have to start actually putting the cube together. And one of the ways that you can do this is start thinking about which sides are going to go together. So sometimes I might actually label the sides so that I can see how things are going to fit together. So I know that the bottom of this circle face is going to meet with this face here. 1 and 1 are going to fit together. I know that here 2 and 2 are going to fit together. The two white faces are going to go together. I know that this green face up here is going to fold down and become adjacent. Oh, goodness me, I've written a 4 out of habit. That should be a 3 as well. And these are the easiest ones to work out because if they're on a right angle, I know that they're going to snap together. From here, we need to think a little bit more carefully about how things are going to go together. I know that the top of this green face here, after 3 and 3 snap together, 4 is going to then snap round to the top of the green triangle. I then know that the other side of this green face, which I'm labeling 5, is going to continue here. And what you can start to see is a bit of a pattern, whereas I'm going round and adding numbers, I'm doing the same in the other direction. So 6 and 6 are going to snap together. And then finally, here 7 and 7 are going to snap together as well. Now that I've worked out which edges are going to come together and become adjacent, I can then start to think about what this means for the cubes. So I can see, for example, that with option A, we have got the circle and the green triangle together as they already were in the net. But I now know that what's going to be above the triangle, where this purple arrow is going to be the other edge 4, which is here. So actually this top face on A is going to be a green face, not white. So using the adjacent rule, A cannot be the answer. I can look at B, and in fact, this is using the orientation rule that the triangle in B is pointing towards the circle, but it's not here. So I can rule out B. And the same is true of C. The triangle is pointing at the circle, but it's not doing that on net. So I can rule out C as well. Now, as is always the case We never assume we have the answer just because we have ruled out the other options. Instead, we must ensure that E is the answer. And we know that A had the circle and the triangle in the right place, but that we needed a green face on the top. And that's exactly what E has. So E is the answer we were looking for. Well done to 46% of you that selected the correct answer. Let's have a look at another question. The poll is live. I'm going to give you exactly 1 minute for this one. Think about the 3 rules. If you've already answered the question, post into the Q&A. What are the 3 rules that I've already mentioned a few times? What are the 3 rules? Lots of people saying hello earlier on, and I'd love to say hello back to all of you. It's lovely to see you all here today. Right, let's scroll to the bottom of the Q&A because there are so many questions coming through. Let's see. Well done, Cesar. Dud is one of the rules. Orientation, well done, Haley, is one of the other rules. And well done, Alice, with the third option is the opposite rule. Dud, orientation, and opposite. Sorry, or the other way around, we learned them. Dud, opposite, and orientation. So we're very well done. Okay, I've already gone over 1 minute. Too busy looking at the Q&A, but let's share the results. Lots of you having selected option A. Let's find out if you're correct. You are absolutely right. Very well done. A number of different ways that we can work this out, but the easiest one is to look at which sides or which edges are going to become adjacent as they move. And we know that the side, the right-hand side of the green triangle is going to become adjacent to the zigzag green line, and that to the bottom left of those is going to be a blank face. So brilliant work. Very confident there. Let's have a look at another question. Slightly more striking images in this one, which is fun. So think carefully about the different rules. Think about, is there anything you can immediately rule out? Are there any duds? Are there any faces that with the net should be opposite that are adjacent on the cubes? If not, are there any adjacent or orientation rules or considerations to make? Should the top of the gnome's head be touching something else? Okay, we're going to stop there. And we can see lots of you having selected option D. Let's go through this one together. Just double check. Let's use a nice red for this one. So first of all, no duds, because all of the images on the 4 options do appear on the net. So we can move on from the dud rule. We're then thinking about opposites. Well, I can see that the gnome and the wolf should be opposite. And in option D, they are adjacent. So D cannot be the answer. We can see this when we're thinking about the lanes. We know that the net is going to form, and the gnome with the green hat and the wolf in the red hood are going to end up being opposite on the cube. So be really careful with that one. We've actually been able to rule out option D first. Thinking about others, thinking about the others that are 1 lane away. So we know that the rainbow is going to be opposite Red Riding Hood. We know that it's not immediately clear looking at the net what the wizard is going to be opposite to. So we need to then start constructing the net. So we can see that the gnome and the... I have read the question the wrong way. Thank you, Natalie, for sending me a message. It cannot be made from this net rather than can. Look at that. Everyone makes mistakes from time to time. You can disregard what I have said. Which cube cannot be made from this net? You're absolutely correct that it is option D. It's the one that we can rule cannot be made. Goodness me, I need to read the question. Maybe I need another coffee. Right, let's have a look at another question. Thank you, Natalie, for being on the ball there. Which option can make the following shape? This is interesting. We're not looking at a cube this time. A very interesting lesson in how important it is to read questions carefully. You can often get into a pattern of assuming that a question is asking for a specific thing, and even I make mistakes from time to time. I try to always be my best, but reading carefully is incredibly important. So which option can make the following shape? You can have a little bit longer for this one, maybe about 10 more seconds. Okay, I'm going to end the poll there. And let's have a look at the results. We can see a generally mixed response here. There are a number of different options, and we need to think very carefully about what these can construct. The first rule, the Dud rule, is thinking, are there any that we can immediately rule out? Now, when we were thinking about nets, we were thinking about whether there are any pictures that appear on one of the nets that don't on the 3D shape, or vice versa. But we can also think about whether or not the net itself can make the shape. So we thought about ways that a net could be arranged that wouldn't even end up making a cube. And one of the options here cannot make this shape. A triangular based prism could also be referred to as a tetrahedron. And we know that D and E are definitely nets of a tetrahedron. We can imagine that the central triangle is the base and all three fold up to form the top point. A and C are also nets of a tetrahedron. The first shape folds in and connects with the third shape along the top, and then the final shape at the end closes the shape with the kind of lid of the tetrahedron. But option B will not make a tetrahedron. We can see if we do some annotations that this side here will meet this side here, and it will end up basically creating a square-based pyramid without the base. It will end up creating an open shape, which wouldn't be a three-dimensional shape, or it wouldn't be considered as a 3D shape in the way that we're looking for it. So we can rule out B. That is a dud. It cannot make a tetrahedron. From here, we're now going to need to think about the way in which these shapes come together. We are looking for a shape that has a black face and a purple face adjacent. And we can see that on option E, there's no purple face. So immediately we can rule that one out. It's not possible. Once again, we're using the Dud rule there, that it doesn't have the required images on the faces to create the shape. The next few we then need to think very carefully about. Can it create this shape? And we can see that option C can come together to create a shape that has a purple and a black face adjacent. And then the white faces are going to come in and be the base and the rear face. However, the purple and black face are going to be the wrong orientation. The purple will be on the left-hand side and the black will be on the right-hand side. The same is true for option D. The two faces will fold up side by side, but the purple will be on the left and the black will be on the right. The correct answer is option A. So well done to those of you that selected that. Let's clear those orientations. Annotations, I should say. Okay, next question. Let's relaunch the poll. Think carefully about this one. It follows the same kinds of rules as the cubes we were looking at, but this is a cuboid. Think about duds, think about opposites, think about orientation. Someone has asked for an orange annotation next, so I will select that and get that ready. Gonna have about 10 more seconds on this one. Seeing a few people in the Q&A saying they accidentally pressed the wrong button, and you've got to be really careful. You've got to make sure to avoid those avoidable mistakes. And you saw an example of one of those today when I read a question wrong, but when you are submitting an answer, you've got to be very careful clicking the correct one as well. Okay, I'm going to end the poll there. And it's looking like you're a little bit more confident when it comes to three-dimensional shapes that have 90-degree angles. And we can see here that there are a variety of different nets that we need to consider. We need to think, are there any that we can rule out straight away? Now, one of the great things about this question is that the faces are all different sizes. And so we can actually use that to our advantage. We know that we're looking for a larger black face. We're looking for a kind of medium-sized white face and a smaller blue face. And so some of these we can rule out straight away. A has got a larger blue face and a larger white face, but we need one that's black. So A cannot be the answer. D has got a larger blue face and a larger white one, cannot be the answer. The other three do have that larger black face, so we now need to think carefully about the other options. So we can see that option C does have the medium-sized white face, and it does have the smaller blue face. But if we would consider the way that this would fold in and come together, the angle that we're looking at this cuboid from, we'd actually be looking at 1 here, 2 here, and 3 here. And so that cannot be the answer. Get rid of those annotations for now. We can rule it out. We've got 2 options left, and we can go back to the Dud rule for this one. We're looking for a smaller blue face here, and on B, they're both white. We can rule it out. We're left with just one option, but as I'm sure you've heard me say many times before, and you will hear me say many times again, E must be double checked. So we can see that it has got the larger black face. That's a good start. It has got the smaller blue face, and it has got the medium-sized white face on both sides. So we need to think carefully, could this fold together to create the right image? And we know that from the angle we're looking at, this would be face 1, this would be face 2, and this would be face 3. It would fold together to come and to make the right shape. And so E is the correct answer. Well done to lots of you that got that one. Very impressed. This is our last question of the day. And this is not relying so much on nets, but on rotations. But those skills are very interconnected. So, which one is a rotation of the main shape? When we're thinking about a rotation of a 3D shape, we need to make sure the whole shape is rotated in the same way and that the orientation of the faces remains the same. Not going to have too much longer on this one because you're looking very confident with this. You're going to have 20 more seconds. So get your answers in when you can. Five seconds. Get those last votes in if you can, because the poll is ending now. Okay, look at this. Very decisive. You're very confident when it comes to rotations of 3D shapes. You can use the same kinds of rules for the next questions as well. Think about, are there any duds? Are there any pictures that are obviously not right? And we can see that with option D, the main face, the largest picture, has been reflected. The letters RAWR are back to front. And so we know that D could not be a rotation of the main shape. We can see that in the smaller image of the dinosaur, his legs need to be touching the edge, which is adjacent to the larger image. And we can see that in option C, his legs are not touching it, so it can't be. And in option A, his legs are not touching it, so it can't be. We're left with one option. We just need to double check. I think if we were to rotate it so that the smaller end was facing us, we've got the legs of the smaller dinosaur facing the right edge. We've got the larger dinosaur still facing the green edge, and we've still got that green edge on the right side. B is the correct answer. So well done to lots of you that selected that correctly. As I expected, we got through this all fairly confidently today, so really well done for paying attention, for demonstrating great understanding. We've looked at nets, the 3 rules, duds, opposites, and orientation, and then we've thought about rotations of 3D shapes as well. Post into the Q&A, let me know, how are you staying positive during lockdown? Looking like schools are probably not going to be opening until Easter now, at least that's what the typical idea is. And so it means we're going to be spending a lot more time together with these online lessons, having fun and learning different things. But what else are you doing to make sure that you're staying positive, that you're looking after yourself, and that you're having a good time? Feel free to let me know in the Q&A, and I will call out some of those responses. Let's get a poll going. Should we look at nets or rotations in one of our warm-up questions next week? I'll leave that poll running as well. From here, I'd love to see you all logging into Atom Nucleus, completing your adaptive activity to test your knowledge, to push yourself to be even stronger in nets and cubes. Fill in the questionnaire, let me know how things are going. Certainly remind me that I need to read questions carefully, and otherwise, Natalie will be sticking around for a couple more minutes to answer any questions that you may have. But from me, really well done for your hard work, and have a great day. Bye-bye.